Before using PowerShell to manage and perform different tasks in Azure, you will need to install the Azure PowerShell module. I must say it's quite simple now. Just type install module AZ. You could also type install module name AZ. Of course, you should be running Windows PowerShell console as an administrator, and the possibility of running scripts on your machine should be enabled. Answer yes if you are requested, and then answer A to install all the components of the module. You could also install module with a force parameter, adding it to the end of your one-liner. So you could type install module name AZ force. Now, as I've mentioned, before using PowerShell to download and install Azure PowerShell module, you must first configure your PowerShell environment with an execution policy that allows scripts to run. Since the default execution policy for PowerShell is restricted, you must change it by running the set execution policy command. And the command looks like this: set execution policy, for example, remote signed. Running this set execution policy command to set the execution policy to remote signed is sufficient for installing Azure PowerShell module from the PowerShell gallery. You could also set your policy to unrestricted, but that would further open up you to unsigned commands that could be malicious. And again, PowerShell will prompt you to confirm that you wish to change the execution policy. Once your execution policy is set to remote signed, you can install the Azure PowerShell module by running the install module command. The installation of Azure PowerShell is generally painless, and once it's done, you can load the module into your PowerShell session if necessary by running import module name AZ or simply import module AZ. But usually it is already loaded for you, and you can go ahead and run the commands. For example, get module list available, and check all the modules which have been downloaded for you from the gallery. You could also check the commands contained in some specific module, for example, get command, module, and pick up any module with AZ name in it. Now, when we are done with installation and checks, we can go ahead and connect to Azure via PowerShell. Although Azure PowerShell supports multiple login methods, the easiest way to get logged in is interactively at the command line, using the Connect AZ account, and then follow the on-screen instructions how to connect to your account. If you are running it on Mac, just copy the address microsoft.com device login and your code to authorize. If you are running it on Windows, type in your email address and password and then the passcode received on your phone. Once you've supplied those credentials, you will be connected to your tenant. To confirm that you are connected to your Azure tenant, you can run the get AZ subscription command from PowerShell to confirm that it returns your subscription information. If it returns your subscription info, you can move on to the next steps in this course. Next up, we'll be talking about deploying a virtual machine with the help of Azure PowerShell module. The objective of this section is to walk you through the process of deploying a VM in Azure using PowerShell. Topics covered in this section include the provisioning of a resource group and the deployment of a VM. Since the deployment of a VM in Azure using PowerShell requires quite a few switches to be specified, each switch will also be explained in detail. So, before deploying a VM in Azure with PowerShell, you need to first create a resource group into which the VM will be deployed. An Azure resource group, by the way, a logical container in which Azure resources are deployed and from where they are managed. Deploying a resource group is rather easy. It is completed with just a single PowerShell command. To provision a group, you need to run the new AZ resource group command. When running the command, you need to specify a name for the resource group and a location for it. So try type a new AZ resource group dash resource group name, for example, VM lab in double quotes, location, for example, East US. In this preceding example, I'm specifying the resource group name and location switches. The preceding command creates a resource group called VM lab, and it creates it in the East US location. Running the new AZ resource group command takes just a moment or two, and once the command completes, you can visit the Azure dashboard to confirm that the resource group has been created. But instead you can run the get AZ resource group PowerShell command without any switches to ensure that the new resource group is listed. So to confirm that your new VM lab resource group has been created, run the following command: get AZ resource group. Upon running the preceding command, you should see a resource group called VM lab listed. Before continuing with the next exercises, if you are following along, be sure that you've created a resource group called VM lab. Now let's provision a VM with PowerShell. When creating a VM, several options are available to you, including operating system image, network configuration, and administrative credentials. However, a VM can also be created with default settings using a minimal configuration. The process of provisioning a VM consists of two different PowerShell commands. The first command, called getCredential, it allows you to specify local administrator credentials for the VM. Once those credentials have been established, you can run the new AZ VM command to configure and deploy a VM. Now, to create a local admin account and password for the VM being deployed, run the following command: $cred equals getCredential. This command results in a prompt to which you can respond by supplying a local admin account login and associated password. The login information provided in the prompt is then used by the VM deployment to provision a local admin for the VM when it is deployed. Running the $cred equals getCredential command stores the local admin credentials that you provide in the $cred variable. After creating the local admin credentials, you can run the new AZ VM command to provision the VM. This $cred variable is referenced during the provisioning process, so that when the VM is provisioned, the local admin info that was provided is used. Now, to provision a new VM, run the entire following command in a PowerShell session: new AZ VM, resource group VM lab, name my VM, location East US, virtual network name my VNet, subnet name my subnet, security group name my NSG, public IP address name my public IP, credential $cred. The preceding command is a single line command, although the command itself is broken up into multiple lines. This command is one long command when written out. To break the command up into multiple lines so that I can better explain it, I used the tick symbol to let PowerShell know it's one long command, despite being supplied over multiple lines. This tick symbol tells PowerShell that even though I'm supplying a multi-line command, it should be interpreted as a single-line command instead. With that said, let's go through the command line by line. As you can see from the preceding command, which takes about 5 to 15 minutes to run, new AZ VM requires some basic information to provision a VM. The resource group name switch tells the command which resource group the VM should be deployed to. In this case, the VM is going to be deployed into the VM lab resource group that was provisioned earlier, if you are following along with these instructions. The name switch specifies the name of the VM being deployed. In this example, the VM is going to be called MyVM. The new VM is deployed into the East US region by specifying the location switch. Since the VM needs to go onto a network and subnet, this command includes the virtual network name switch and subnet name switch. In preceding example, the VM is being deployed to a virtual network called MyVNet and to a subnet called MySubnet. Because we haven't created a virtual network yet, nor a subnet, the new AZ VM command is going to create them automatically using default IP range values. Had we previously provisioned a virtual network and virtual subnet, we could specify their names instead, and the VM would be deployed to them. To protect the VM, a network security group needs to be deployed. The provision and associate a network security group with a new VM, the security group name switch is used. In this example, the network security group is called MyNSG. As was the case with the virtual network and virtual subnet, had we pre-provisioned another security group, we could have specified that group with a security group name switch. Now, to be able to RDP to the new VM over the internet from a workstation, we need to give the VM a public IP address. This is done with the public IP address switch. In this example, the public IP address resource is called MyPublicIP. In a production environment, assigning a public IP address and enabling RDP for a VM is a terrible practice. You never want to make RDP available over the internet on a production machine. I'm simply enabling RDP in this case for ease of use, so I can more easily work through the deployment process. Now, we must tell the new AZVM command what local admin credentials to provision for this VM. To do this, I'm specifying the credential switch and referencing the $cred variable with it. With all this information provided, running the new AZVM command will deploy a default Windows 16 server into the East US region onto a new subnet called MySubnet, which is part of a virtual network called MyVNet. The VM will be protected by a default set of rules contained in a network security group called MyNSG. And the VM deployed with the preceding command is called MyVM, and it will be deployed into a resource group called VMLab. It will assign a dynamic public IP address that is accessible from the internet and the local admin account, which will match what was configured when we ran the getCredential command. And as I said, the VM deployment process can take several minutes to complete, but when it is done, you will have a fully functioning virtual machine deployed. And once the deployment is complete, you can confirm in the Azure dashboard that the VM is up and running. You can also run the following command instead: get azvm resource group VMLab name myvm status. The output of the preceding command will show the status of your newly deployed VM. Congratulations, now you've created your first Azure VM. Next up, we'll be talking about connecting to a VM with RDP from PowerShell, resizing a VM with PowerShell, and virtual machine power states. I'll see you there. Once our first virtual machine is deployed, you can create a remote desktop connection with a VM right from your PowerShell session. To do so, you need to run two commands. First, you need to track down the public IP address of the VM by running the getAZ public IP address command. This command will display the public IP address of the VM. You can then use this IP to connect to the VM. To obtain your public IP address of the VM named myVM, which we've deployed in the preceding example, run the following command: getAZ public IP address name myPublicIP resource group name VM pipe select IP address. The getAZ public IP address command displays the public IP for the VM. All you have to do is tell the command which public IP resource you want to query, and then pipe that data to a select statement. The output is the public IP address of your virtual machine. Now, to connect to the virtual machine via RDP, you can run the mstsc.exe command right from the PowerShell session and replace public IP address with the IP address of the VM. So the command looks as follows: mstsc.exe/v: your public IP address acquired from the preceding example. And in the security window, supply the local username and password that you created for the VM and then click OK. The RDP client session will launch, and then you can log into the newly provisioned virtual machine. Logging into the new virtual machine from this point forward is no different from any other RDP session. Now, some words about resizing a VM with PowerShell. There will be times when an application will require more resources than it once did. In such cases, an Azure VM can be resized. Resizing a VM requires the use of two different PowerShell commands. The first command, called getAZ VM size, is used to retrieve a list of VM sizes available in a chosen region. Before resizing a virtual machine, you must ensure that whatever size you want to change the virtual machine to is available in the virtual machine's region. The getAZ VM size command does exactly this. And the second command that is required, the update AZ VM command. This command is used to update a VM after changing its size configuration. So to resize the myVM virtual machine that you created earlier, you need to retrieve a list of VM sizes available in the East US region, which is where the myVM virtual machine resides. To complete this task, run the following command from PowerShell: getAZ VM size location East US in double quotes. This preceding command should return quite a few sizes. Confirm that needed size is available. If it's not, find another size that is available. After doing so, you can use PowerShell to resize the myVM virtual machine. So to resize the virtual machine myVM, you need to run a few different PowerShell commands. The first command essentially loads the configuration profile of the VM into a variable called $VM. The second command will modify the VM size attribute stored in the variable to reflect the new VM size. The third command, called update AZ VM, will take the updated configuration that is stored in the $VM variable and write it to the VM. To begin the resize process of the myVM virtual machine, run the following command from a PowerShell session that is connected to your Azure tenant. $VM equals getAZ VM, resource group name VMLab, VM name myVM. This preceding command retrieves the current VM information and stores it in the $VM variable. To modify the size attribute, for the VM, run the following command: $vm.hardwareprofile.vm_size equals, and the size you want to be changed to. Once the new size has been specified using the preceding command, run the following command to update the VM. Update azvm-vm $vm resource group name VMLab. After executing the preceding update azvm command, the my VM virtual machine is updated and then automatically restarted. The process takes a few minutes to complete, but when it completes, the my VM virtual machine is resized to reflect the new size. And finally, for this lesson, let's take a look at virtual machine power states. If you manage any number of Azure VMs on a day-to-day basis, you're going to need to understand the different states in which VMs can exist. Here I want to briefly touch on the available power states for a VM and on how to check the current power state on a VM via PowerShell. There are several power states that a VM can exist in. Starting indicates that the virtual machine is being started. Running indicates that the VM is running. Stopping indicates that it's being stopped. Stopped indicates that the VM is stopped. Please note that VMs in the stop state still incur compute charges. Deallocating indicates that the VM is being deallocated. Deallocated indicates that the virtual machine is completely removed from the hypervisor but still available in the control panel. VMs in the deallocated state do not incur compute charges. Unknown indicates that the power state of the VM is unknown. Although most of these are self-explanatory, I wanted to ensure that you were aware of them. Especially note stopped and stopping states, deallocating and deallocated. For stopped state, you'll get compute charges, and for deallocated state, you do not incur compute charges. Now, to retrieve the status of a VM is rather straightforward. To retrieve the state of a specific virtual machine, use the getAzVM command, taking care to specify valid names for the VM and the resource group. Run the following command to check the status of the my VM virtual machine. getAzVM resource group VMLab name my VM status. This preceding command retrieves the current status of the my VM virtual machine. While the output will include quite a bit of information, what we are most concerned about for this exercise is the part that shows whether the VM is running. The resulting output indicates the current status of the VM. Next up, we'll see how to perform basic management tasks, how to stop virtual machine from PowerShell, to start it, restart, and remove virtual machine command. And finally, we'll remove resource group. I'll see you there. Day-to-day operations will often require you to perform several management tasks such as starting, stopping, and deleting virtual machines. In addition, you may find yourself in situations where you will need to create scripts to automate certain VM tasks. By becoming familiar with how to use Azure PowerShell, you can script and automate many common management tasks that would otherwise require manual intervention. The 5 main commands I'm going to cover in this section are stop AZVM, start AZVM, restart, remove, and remove AZ resource group. So to stop an Azure VM, you can use the stop AZVM command. Go ahead and run the command to stop the my VM virtual machine. To do this, type stop AZVM resource group VMLab name my VM force. The only switches required in the preceding command are the resource group name switch and the name switch. The fourth switch is optional, but it shuts down the VM without asking for confirmation. Another optional switch is the stay provisioned switch. If you wish to stop a VM but keep the virtual machine allocated, you could specify the state provisioned switch as well. Keep in mind that if you do this, you will continue to be charged for compute cycles even though the VM is off. Once you've stopped the myVM virtual machine, run the get azvm command to confirm the status of it. So the command looks as follows: get azvm, resource group name vmlab, name myvm, and status. This preceding command will display the status of the myVM virtual machine and should show the status of deallocated. Now, to start a VM, you can use the start azvm command. Run the following command to start the myVM virtual machine. Start azvm, resource group name vmlab, name myVM. This preceding command starts the myVM virtual machine in the vmlab resource group. And again, to check the status, you can use get azvm as before. Get azvm, resource group vmlab, name myVM, status. Now, to restart VM, we can use restart azvm command. You can run the following command to restart myVM virtual machine. Restart azvm, resource group name vmlab, name myVM. This preceding command restarts the myVM virtual machine in the vmlab resource group. And again, you can check the status using get azvm command. If you want to remove VM, we can use the following command: stop azvm and remove azvm. So there will be times when you need to decommission a VM. Doing so is performed with the stop azvm command. However, before deleting a VM, it should be first stopped. In this example, we'll stop the myVM virtual machine and then delete it. So let's stop it by running the following command: stop azvm, resource group name vmlab, name myVM, force. Once the VM is stopped, run the preceding remove az command to delete the VM. Type the following: remove azvm, resource group name vmlab, name myVM. As was the case with the stop and start commands, only the resource group name and name switches need to be provided. After a few minutes, run the following command to see whether the myVM virtual machine has been deleted. Get az VM status. If you've successfully deleted the VM, it should not be shown in the output of the preceding command. The only hassle with the remove az VM command is that it only removes the VM. It does not clean up other resources that are attached to the VM, such as NICs and additional disks. They need to be cleaned up manually unless you opt to script their removal. So the final command that I want to cover is remove az resource group command. This command removes an entire resource group, and it can be used quite regularly since you often create different specific resource groups. Once I'm done with the labs and courses, I just delete the resource groups that all resources inside the resource groups and their entity are removed simultaneously. This makes my life easier. So to remove the entire vmlab resource group, run the remove az resource group command. Don't worry, we'll be recreating it later in this course. So just type remove az resource group name vmlab force. Running this command tells Azure to delete the vmlab resource group and everything inside it. The force switch suppresses all the prompts that need to be answered. Although this command can sometimes take a while to complete, when it does complete, the entire resource group is removed along with everything inside of it. After running the preceding command, run the following get AZ resource group command to confirm that the VM lab resource group is gone. Now, when we are done with these first lessons on Azure VM, you can apply what you've learned in this section by completing the following project. You can call the project common commands. The goal of the project is to successfully deploy a VM and to practice stopping, starting, creating, and removing it. The commands for this project are as follows: new AZ resource, get AZ resource group, new AZ VM, get AZ VM, stop, start, remove AZ VM, remove AZ resource group. The general steps for this project are as follows. First, you can create a resource group, then deploy a VM with a default configuration, stop the VM, start the VM, delete the VM, and delete the resource group and all its resources. After completing this project, ensure that the VM deploys and that it stops and starts as expected. I hope that these tasks are quite simple for you and you'll manage to perform them easily. Next up, we'll be working with images. I'll see you there. Welcome to Working with Images. Now that you've gone through and learned some of the Azure PowerShell basics in the previous lessons, we're going to take a look at some image-centric tasks and commands that you should know how to handle as part of your day-to-day operations. So in these few videos, we'll cover the following topics: marketplace images and custom images. By the end of this section, you should know how to deploy virtual machines from the existing images that are available on the Azure Marketplace and from custom created images. You'll even get the opportunity to practice what you've learned by working through a hands-on exercise at the end of this video. Although a virtual machine can be deployed in Azure with default options, the Azure Marketplace offers numerous virtual machine images that can be used to create a new virtual machine. If you are following along, you previously deployed a virtual machine called MyVM using the default Windows Server 2016 data center image. That's because you didn't choose a specific image to use. However, here I'm going to explain how to use PowerShell to search the marketplace for other Windows images and how to deploy a new virtual machine in Azure using one of these images. Before performing any exercises in this video, you run the following command to recreate VM lab resource group if you've deleted it. New AZ resource group name VM lab, location East US. This command should generate the output you've got resource group VM lab created in East US location. And to confirm that your new VM resource group exists, run the following command: get AZ resource group. Ensure that the new VM lab resource group is listed. Now, the key commands for this video. The process of deploying a virtual machine using a specific image includes finding a publisher, finding an offer from the publisher, and then locating a SQ for the image to use. To work through this process, you need to run three different PowerShell commands. Get AZ image publisher. This command returns a list of image publishers. Get AZ VM image offer. This command returns a list of image offers from a specific publisher. And finally, get AZ VM image SKU. This command will filter on the publisher and offer name to return a list of available image names. The process seems a bit complicated, but it's not terribly difficult. Once you've done it a few times, it really does become second nature. So first, to track down an image to deploy from, launch a PowerShell session, connect to the Azure tenant and use the following command: get az VM image publisher, followed by location East US. And you'll see a list of publishers available in the East US location. Then make sure Microsoft Windows Server is listed, since this is the publisher that provides Windows operating system images on the marketplace. And after ensuring that Microsoft Windows Server is listed, run the get az VM image offer command to see what image offers are available in the East US location from the Microsoft Windows Server publisher. So the command looks as follows: get az image offer, location East US, publisher name Microsoft Windows Server. And you'll see what Microsoft Windows Server offers are available in East US. And to deploy a Windows virtual machine, you'll want to ensure Windows Server is one of the choices available. The following command will show the available image offers from the Microsoft Windows Server publisher in the East US location. Then track down available image names within the Windows Server offer using the get az VM image SKU by typing the following command: get az VM image SKU, location East US, publisher name Microsoft Windows Server, offer Windows Server. Running the preceding command returns quite a few options. Keep in mind that the list you see is filtered based on the specified publisher and image offer. For this exercise, you'll want to ultimately choose the 2016 data center option, since that is the operating system we are going to deploy in the exercise. You'll see many different SKUs that are available through the Windows Server offer from the Microsoft Windows Server publisher. Now that you know which publisher you're using, which offer you will need, and which image you're going to deploy from, you can deploy a virtual machine using your chosen image. And when we've decided we would use the 2016 data center image for a new virtual machine, we're going to deploy a virtual machine based on this image within the Windows Server offer from the Microsoft Windows Server publisher. So to deploy the new virtual machine, which we are going to call MyVM2, you need to first capture some credentials to use as the local admin for the new virtual machine. And to specify the local admin credentials for the new virtual machine, run the following command: $cred equals get credential. Now, to deploy a new virtual machine called MyVM2 using the preceding information, run the new az VM command in a PowerShell session that's been connected to your Azure tenant. And type the following one-liner: new az VM, resource group VM lab, name MyVM2, location East US, virtual network name MyVNet, subnet name MySubnet, security group name MyNSG, public IP address name MyPublicIPaddress2, image name Microsoft Windows Server Windows Server 2016-data center latest, credential $cred, and will run it as job. You might notice that the preceding command looks very similar to the original command that we used earlier in this course to provision the individual virtual machine called MyVM using the default image. However, if you look closely at this new iteration, you'll see two new switches added to it. You'll see image name specified as well as job. These are two new switches that were introduced when the MyVM virtual machine was first deployed. The image name switch specifies the value returned by the getAZVMImageSkew command in the previous video. This is the switch that tells Azure what specific image to deploy the new virtual machine from. And the asJob switch creates the virtual machine as a background task and returns control of the PowerShell prompt to you, as you can continue working without needing to wait for the previous command to complete. Since this command is deploying a virtual machine, it can take a while to complete. After a few minutes, usually 5 to 10 or so, the new MyVM2 virtual machine will be deployed. Before continuing, you can run the following getAZVM command and confirm that the MyVM2 virtual machine is deployed and running. So the command looks as follows: getAZVM resource group VM lab, name MyVM2, status. Assuming you did everything right, you will be able to see the following output indicating that the new MyVM2 virtual machine has been deployed and is running. Now let's use custom images. So far you've learned how to create a virtual machine using the default image. You've also learned how to deploy a virtual machine using a specific image from the marketplace. But sometimes, though, a default or marketplace image just isn't sufficient for a virtual machine's deployment. An example of this is in real world would be a case where several virtual machines with a particular application installed are needed. Another example would be a case where a gold image server image is maintained so that when a virtual machine is deployed from it, the server that gets deployed is already fully patched, negating the need to spend hours patching it up to date. So custom images are essentially the same as images available on the marketplace. However, custom images are created by you. By using custom images, you can deploy pre-configured servers, saving yourself hours of post-deployment configuration. So in this video, we'll create a custom image of an Azure virtual machine and use it to deploy a customized virtual machine. And you'll learn how to do the following: sysprep and generalize a virtual machine. Create a custom image from an existing virtual machine. Create a new virtual machine from a custom image. List all the images in an Azure subscription. And delete an image. Now, throughout the rest of this exercise, I'm going to walk you through steps required to take an existing virtual machine, create a custom image from it, and then use that image to deploy a new customized virtual machine based on this image. To follow along with this exercise, you need to have an existing Windows 2016 virtual machine called MyVM2 in Azure to work with this machine. It should be deployed as a resource group called VM Lab, which we've created before. The first step in deploying a virtual machine based on a custom image is to prepare the source virtual machine. Creating an image from a source virtual machine requires the source virtual machine to be generalized and deallocated. Once this has been completed, the source virtual machine needs to be marked as generalized in Azure. Only after these tasks have been completed can an image be created from the virtual machine. So let's start using sysprep. Sysprep is a tool that's used to generalize the source virtual machine. It is a Windows utility that essentially removes all account information from a machine. What this tool does is remove security information such as the SID, GUID from a virtual machine, and then it prepares the computer for a first-time boot, much like a new laptop would behave upon the initial boot. Removing all security information from a virtual machine allows an image of this machine to be taken and used over and over without duplicate SIDs, GUIDs, causing issues related to having multiple identical computers on the network. And to begin the process of preparing my VM2 virtual machine to be used as an image, perform the following steps. First, log into the virtual machine using RDP and launch the command prompt as an administrator. Get the public IP for the virtual machine so you can RDP to it by running the following command. Get AZ public IP address, name my public IP address to. Resource group VM lab, select IP address. And once you've logged into my VM2, launch the command prompt as an admin and change the Windows System 32 sysprep directory, and then run sysprep.exe. From the System Preparation Tool dialog box, choose Enter System Out-of-Box Experience, or OOBE, and make sure that the Generalize checkbox is checked. In the Shutdown options, select Shutdown and click OK. Clicking OK launches the sysprep process. When sysprep completes, the virtual machine is automatically shut down. Now, before creating an image from the source virtual machine, when it is prepared with sysprep, the virtual machine must first be deallocated and marked as generalized in Azure. So first confirm the MyVM2 virtual machine has been shut down by running the getAzVM command. We'll type the following: getAzVM name MyVM2, resource group name VM lab, status. Then second, stop and deallocate the virtual machine by running the following command: stop AZVM, resource group name VM lab, name MyVM2, force. Then run the getAzVM command to be sure the virtual machine is stopped and deallocated. So we'll type getAzVM, name VM2, resource group name VM lab, status. And once the virtual machine has stopped and shows deallocated, when you run getAzVM, set its status to generalized using the setAzVM command. We'll type setAzVM, resource group VM lab, name MyVM2, generalized. And again, we'll check the status, which after running the preceding command deallocates the source virtual machine and makes it as a generalized, preparing it for the imaging process. So confirm that the machine is generalized status. Now let's create an image. With the source virtual machine, which is MyVM2, generalized and deallocated, it can now be used to generate an image. Creating an image requires the use of two different PowerShell commands: new AZ image config and new AZ image. To create an image from MyVM2, three things need to happen. First, the MyVM2 virtual machine config needs to be loaded into a variable. Second, the image configuration needs to be created from MyVM2. And third, the actual image needs to be created. So follow these instructions to complete the necessary steps. First, let's retrieve the source VM. Run the following command to retrieve the source MyVM2 info and store it in a variable. We'll type $VM equals getAzVM name MyVM2, resource group name VM lab. This command will not generate any feedback on the screen, since all it's doing is loading info into a variable. Next, let's create an image configuration. We'll run the new AZ image config command to create an image configuration that will be used to create an eventual image. So we'll type $image equals new AZ image config, location East US, source virtual machine ID, $VM.id. Now let's create an image. This last step in the image creation is the actual creation of the image from the image configuration. We'll run the new AZ image command to create the actual image. We'll type new AZ image, $image, image name my image, resource group name VMLab. Upon completion of the preceding steps, you're left with a new image called my image. This image, based on the my VM2 virtual machine, can be used to deploy additional virtual machines that will be configured identically to my VM2. Once an image has been created, it can be used to provision additional virtual machines. Creating a new virtual machine in Azure from a custom image isn't terribly different than creating a virtual machine using a typical marketplace image. When you deploy an Azure virtual machine from a marketplace image, you must provide information about the image publisher, the author, the SKU, and the version. Using a basic set of parameters or switches for the new AZVM command allows you to adjust of the custom image if it is in the same resource group as the virtual machine you are deploying. The following new AZVM command will provision a new virtual machine in Azure called myVM3 using the image called myImage. Run the command to create a new virtual machine called myVM3, and the command looks as follows: new AZVM, resource group name VMLab, name myVM3, image name myImage, location East US, virtual network name myVNet, subnet name mySubnet, security group name myNSG, and finally public IP address name myPublicIP3. Because you didn't create local admin credentials before running the preceding command, you will be prompted to create local admin credentials. Once you supply them, the new myVM3 virtual machine will be provisioned, so running the new AZVM command should produce output similar to mine, which you can see on my screen. Once the preceding command completes, run the following command to retrieve the public IP for myVM3 and use it to RDP into the new virtual machine and confirm it functions as expected. So run get AZ public IP address, name myPublicIP3, resource group name VMLab, select IP address. Once you've confirmed the new virtual machine works as expected, continue with the next exercise. So deploying a new virtual machine from an image is all well and good. However, it helps to know how to perform some basic image management tasks as well. You can use the following instructions to perform some common image management tasks in PowerShell. Now we can find or list the images by name by typing find AZ images. We can also delete an image. The following command deletes the myImage image from the VMLab resource group. We'll type remove AZ image, image name, myImage, resource group name, VMLab. Don't worry, deleting the image won't break the virtual machine that you deployed from it. The image just won't be available to create any more VMs. So congratulations, you've now learned how to create a disk image from an existing virtual machine and then use that image to deploy a new virtual machine, and all with PowerShell. Now you can try to perform these all steps we've performed in the previous videos and do it yourself. So the project for this task is custom images, custom disk images. The goal is to successfully provision a virtual machine based on a disk image taken from an existing virtual machine. The key commands for this exercise are as follows: new AZ resource group, get AZ public IP address, get AZVM, stop AZVM, set AZVM, new AZ image config, new AZ image, get credential, new AZVM, and remove AZ resource group. The steps for this exercise are as follows. First, create a resource group. Then deploy a virtual machine with a default configuration. Then take an image of the operating system disk of the virtual machine. Then delete the virtual machine. Step 5. Deploy a second virtual machine from the image. And finally, delete the resource group and all resources. As a result, ensure that the new virtual machine deploys successfully by logging into it after deploying it from the disk image. In your day-to-day operations, you'll often find that you need to perform tasks such as snapshotting of the disks. In this video, you'll cover the following topics: Azure Data Disks, snapshotting an Azure virtual machine, and creating VMs from snapshots. This video includes hands-on exercises that allow you to practice your skills with data disks and snapshots. As a result, you will know how to create and attach data disks, snapshot them, and even deploy new VM from them. So, Azure virtual machines use disks to store the operating systems, applications, and data. Choosing an appropriate disk size and configuration is critical when creating a virtual machine. You want to make sure that you size and configure your disks to match whatever workload the server will be handling. The following exercises cover deploying virtual machine, data disks, and managing them. The next few exercises will teach you how to know the difference between operating system disks and temporary disks, what data disks are, the difference between standard disks and premium disks, disk performance, how to create data disks, how to attach a data disk to a virtual machine, and how to prepare a data disk for use. When you finish these exercises, you'll have a solid understanding of the different types of Azure disks, how to create them with PowerShell, and how to manage them with PowerShell. So when an Azure virtual machine is created, two disks are automatically attached to the virtual machine. They include the operating system disk and a temporary disk. Operating system disks, which host the virtual machine's operating system, can be up to 4 terabytes. The OS disk is assigned a drive letter of C by default, and its disk caching configuration is optimized for operating system performance. It is not recommended to use the operating system disk to host data or applications. Instead, for applications and data, use a data disk, which is detailed later in this video. Some words about temporary disks. Temporary disks use a solid-state drive that is located in the same Azure host as the virtual machine. This temporary storage is typically used to save the system paging file, but can be used to store other data that you can afford to lose. There is no extra storage associated with this temporary storage. Temporary disks are high performance and can be used for operations such as temporary data processing. However, if the virtual machine is moved to a new host, then the data stored on the temporary disks will be removed. The size of a temporary disk is generally determined by the virtual machine size, and they are typically assigned a drive letter of D by default. The sizes of temporary disks can be changed, but for now it is like for general purposes, A, B, and D series, compute optimized, memory optimized, storage optimized, GPU, and high performance. Now, data disks are recommended when durable and responsive data storage is required. Each data disk has a maximum size of 4 terabytes as for now. However, multiple data disks can be attached to a virtual machine. When installing applications and storing data, data disks should be used. The size of the virtual machine determines how many data disks can be attached to it. The number of virtual CPUs is typically what drives this. Data disks can be also general purpose, compute optimized, memory optimized, storage, GPU, and high performance. Azure provides two types of disk. This includes standard disks and premium disks. Standard disks are typically lower performance and are used for general purpose storage. Premium disks are higher performance and are used when higher I/O is required. So premium disks are backed by solid-state technology. Premium disks are a good choice for production virtual machines and VMs that require high I/O. Now, creating a disk and attaching it to a virtual machine requires 4 steps. The first step is to create the initial disk configuration. Once the configuration is created, the actual data disk resource is created. After creating the configuration and the actual data disk, the data disk is added to the virtual machine configuration. Lastly, the virtual machine configuration is updated to include the new disk. The following exercises demonstrate how to create a new data disk and how to add the data disk to the MyVM3 virtual machine. Follow these instructions to create a new data disk and to attach the data disk to the MyVM3 virtual machine. So let's create the data disk configuration first. We'll create the initial configuration with the new AZ disk config command. This following command configures a disk that is 128 GB in size. So we'll run it. The new disk configuration is stored in a variable called $diskconfig, so it can be more easily referenced in later commands. The command looks as follows: $diskconfig equals new AZ diskconfig, location East US, create option empty, disk size GB 128. This preceding command generates no feedback on the screen. Then let's create the data disk itself. With the data disk configuration created, let's create the actual data disk with the new AZ disk command. And let's type the following one-liner: $data disk equals new AZ disk, resource group name VMLab, disk name data disk $diskconfig. This command takes a few minutes to complete and produces no feedback on the screen. New AZ disk creates an actual data disk resource that's based on the disk configuration that you created in the first step. After that, let's add the data disk to the virtual machine. With the data disk created, get the virtual machine that you are adding the data disk to by running the following get AZ VM command. And the command looks as follows: $VM equals get AZ VM, resource group VMLab, name MyVM3. The preceding command retrieves the virtual machine configuration for the MyVM3 virtual machine and loads it into a variable called $VM. You can add the data disk to the virtual machine configuration using the add AZ VM data disk command. Now let's perform the following command: $VM equals add AZ VM data disk, $VM name data disk, create option attach, managed disk ID $datadisk.id, LUN1. This command doesn't actually update the virtual machine yet. It adds the new data disk to the virtual machine configuration. The next step will take the updated configuration and update it to the actual virtual machine. Now, let's update the virtual machine. With the data disk configuration added to the virtual machine configuration using the preceding command, the virtual machine can be updated using the update azvm command. So we'll type update azvm, resource group name vmlab, vm $vm. This preceding command adds the actual data disk to the virtual machine so that the operating system of the virtual machine can see it. This can take a minute or two to complete. Now let's prepare data disks. After attaching a data disk to a virtual machine, the disk must be configured within the operating system on the virtual machine itself. The disk must be initialized and partition created. The partition must be then formatted just like any other physical disk would be. The following demonstration shows how to manually configure a data disk added to a virtual machine. So to manually configure the newly attached data disk on MyVM3, simply create an RDP connection to the virtual machine and open PowerShell on it. And run the following command in the PowerShell session and hit enter. The command looks as follows: get disk pipe where partition style equals raw pipe, initialize disk partition style mbr, path through. Pipe it to new partition, assign drive letter with use maximum size parameter, and pipe it to format volume with file system NTFS parameter. And two more parameters: new file system label data disk and confirm false. The preceding command is one long command. It retrieves the raw disk using the get disk command. From there, it pipes the information to the initialize disk command so that the disk can be initialized within the operating system. Once the disk is initialized, the new partition command creates a new partition that equals the size of the disk. Lastly, the format volume command formats the new volume so that it can be accessed by the operating system. Now you can try to do it by yourself. And the project name for this lab is Data Disks. The goal is to successfully provision a data disk connected to a virtual machine and make it available to the operating system on the virtual machine. The key commands for this lab are as follows: new AZ resource group, new AZ VM, new AZ disk config, new AZ disk, get Azure VM, get AZ VM, add AZ VM data disk, update AZ VM, get disk, initialize disk, new partition, format volume, and remove AZ resource group. The exercise steps are as follows. First, create a resource group. Second, deploy a virtual machine with a default configuration. Then create a data disk, attach the disk to the virtual machine, and initialize and format the attached data disk. Then validate your actions. To do this, log into the virtual machine and confirm that the new data disk is available to the operating system and is writable by creating a text file on it. Now, in this video we'll be talking about snapshotting an Azure VM disk. Another way to create custom virtual machine is to deploy them from an existing snapshot from another virtual machine. To do this, you first need to create a snapshot of an existing virtual machine. The following exercises show you how to create the snapshot configuration for an existing virtual machine and how to take a snapshot on the disk using the new AZ snapshot commandlet. Now, before snapshotting a virtual machine, A few parameters or variables need to be set so they can be more easily referenced later. We need to set the resource group name, the location where the source virtual machine resides, and a name for the snapshot. Run the following commands to set the parameters to create a snapshot of myVM3. So the variables are as follows: $resource group equals VMLab, $location equals East US, $VM name equals myVM3, and the final variable $snapshot name equals mySnapshot. These commands generate no output. With that done and command variables set, you can then retrieve the configuration of the myVM3 virtual machine and store it in a variable called $VM. Once the existing configuration of myVM3 is stored in the variable, it will be used to create the snapshot. So we'll run the following command: get azvm command to retrieve the myVM3 virtual machine configuration and store it in the variable. So we'll type $VM equals get azvm resource group $resource group name $VM name. This command takes a few moments to run, so you could wait a bit. Once the parameters have been set and the source virtual machine configuration has been retrieved, we can create the snapshot configuration, and to create the snapshot configuration, run the new az snapshot config command. So the command looks as follows: $snapshot equals new az snapshot config, and the parameters source URI $vm.storageprofile.osdisk.manageddisk.id, location $location, and create option copy. This command provides no feedback on the screen. Now let's take the snapshot itself. After creating the snapshot configuration, the actual snapshot of the source virtual machine myVM3 can be taken using the new az snapshot command. To create the actual snapshot, run the following command: new az snapshot $snapshot snapshot name $snapshot name resource group name $resource group name. This command creates the snapshot based on the snapshot configuration that you previously stored in the $snapshot variable. By specifying the VMLab resource group with the help of $resource group name variable that you set earlier, the snapshot is stored in the VM resource group. And once the snapshot is completed, you can create a virtual machine from it by creating a managed disk from the snapshot and then attaching the new managed disk as the operating system disk. You will create a new virtual machine from this snapshot later on. So now when we are done with snapshot, once it has been taken, the snapshot of an existing virtual machine, it can be used to create a new virtual machine. Now we will cover the deployment of a new virtual machine using a snapshot as the operating system disk for the new virtual machine. The process of deploying a new virtual machine using a snapshot includes a few different steps. The first step is to load up required variables with information about the snapshot and the disk config from the new virtual machine. Once the variables are loaded, the configuration for the new virtual machine needs to be initialized. This process includes setting the virtual machine size, deploying a public IP address, provisioning a network internet card, and telling the process which virtual network to deploy the virtual machine to. After initializing the configuration for the new virtual machine, the virtual machine can be created. So we'll do this in the next video. I'll see you there. Let's start with loading variables. Loading the necessary variables requires 3 commands. The first command loads the existing snapshot that was created into a variable called $snapshot. The snapshot info needs to be loaded in a variable so that it can be more easily referenced in commands used later in this process. So to load the snapshot config for the mySnapshot into a variable by running the following command: $snapshot equals getAZ snapshot, resource group name VMLab, snapshot name mySnapshot. Once the snapshot config is loaded into a variable, you need to create a new disk configuration and load that into a separate variable so that it too can be referenced more easily. So we'll type $diskconfig equals new AZ disk config, location $snapshot.location, source resource ID $snapshot.id, create option, copy. After loading the new disk configuration into a variable using the preceding command, you need to create a new operating system disk resource based on the configuration you just loaded. To create the OS disk resource based on the preceding configuration, run the new AZ disk command. So we'll type $equals new AZ disk $diskconfig, resource group name VMLab, disk name myOS disk. None of these three commands is going to precede any feedback on the screen. However, they are loading up the snapshot configuration, creating a disk configuration based on the snapshot that was taken, and provisioning a new OS disk from the snapshot. Now let's initialize the virtual machine configuration. Initializing the new virtual machine that will be deployed from the snapshot requires quite a few steps. First, a configuration for the new virtual machine needs to be loaded into a variable so it can be modified. Next, the OS disk needs to be appended to the virtual machine configuration that's stored in the variable. After that, the network info needs to be added to the virtual machine configuration. This info includes adding a public IP, setting the virtual network that the virtual machine will attach to, and setting the NIC and subnet for the new virtual machine. This info is all set up by loading it into variables. So we'll run the following commands to set up the configuration for the new virtual machine being deployed from the image. $VM equals new AZ VM config, VM name myVM4, VM size standard A2v2. Use the manage disk resource ID to attach it to the virtual machine by typing the following: $VM equals set AZ VM OS disk VM $VM manage disk ID $disk ID, create option, attach, Windows. Then run the following command to create a public IP for the new virtual machine, which is myVM4. $pip equals new AZ public IP address, name myPublic IP4, resource group name VMLab, location $snapshot.location, allocation method dynamic. Then retrieve the configuration of the virtual network where the new virtual machine will be hosted. In this example, the new virtual machine is being deployed to the myVNet virtual network. So we'll type $vnet equals get AZ virtual network, name myVNet, resource group name VMLab. And then we'll create the NIC in the first and only subnet of the myVNet virtual network. So we'll type $nic equals new AZ network interface, name myNIC4, resource group name VMLab, location $snapshot location, subnet ID $vnet.subnets in square brackets 0.id, public IP address ID, $pip.id. And finally, we'll add the newly configured NIC to the configuration of the new MyVM4 virtual machine. We'll type $VM equals add Azure at AZ VM network interface VM $VM ID $nic.id. So that was a lot of work. And now the configuration for the new virtual machine is now set. Now let's create the actual virtual machine. With all this configuration set for the new virtual machine, which is MyVM4, we can now create the new virtual machine by running the new azvm command, referencing the virtual machine configuration stored in the $VM variable. So we'll type new azvm, VM $VM, resource group name VMLab, location $snapshot.location. The process takes a few minutes to complete, since we're deploying a new virtual machine. However, when it completes, you'll be notified on the screen. Once the deployment process completes, you can confirm the existence and status of the new virtual machine by running the getazvm command. By typing getazvm name myvm4, resource group name VMLab, status. This command will retrieve the current status of the new MyVM4 virtual machine. Now it's your turn. The name for this lab is Snapshots. The goal is to create a virtual machine, snapshot it, create a disk from the snapshot, and deploy a new VM from the disk. The key commands for this lab are as follows: new AZ resource group, get azvm, new AZ snapshot config, new AZ snapshot, get AZ snapshot, new AZ disk config, new AZ disk, new AZ VM config, set AZ VM OS disk, then new AZ public IP address, get AZ virtual network, new AZ network interface, add AZ VM network interface, new AZ VM, get AZ VM, and remove AZ resource group. The exercise steps are as follows. First, create a resource group, then deploy a virtual machine with the default configuration, take a snapshot of the virtual machine, delete the virtual machine, then deploy a second virtual machine from the snapshot and delete the resource group and all resources. High availability with PowerShell on Azure. So when deploying virtual machines in Azure, it's important to consider availability, whether it's built in with unplanned maintenance, outages, or even load balancing in mind. It's critical to build virtual machines that can withstand any scenario. So further on, we'll be covering the following topics: availability sets and load balancers. At the end of these few videos, you'll also have the opportunity to work through a hands-on exercise to practice your skills with availability sets and load balancers. So with that said, now we are going to complete some exercises that will teach you how to increase the availability and reliability of your virtual machine solutions on Azure using availability sets. Availability sets ensure that the virtual machines you deploy in Azure are distributed across multiple isolated hardware nodes in a cluster. Deploying multiple virtual machines in an availability set ensures that if a hardware or software failure within Azure happens, only a subset of the virtual machines are impacted and your overall solution remains available and operational. So further on, you'll learn how to create an availability set, create a VM in an availability set, check available VM sizes, check Azure Advisor. And when we are done with these exercises, you should know how to deploy the basic HA functionality that comes with availability sets. So let's take a few moments to find out what's availability set. An availability set is a logical grouping of Azure virtual machines that you can use to ensure that the virtual machines you place within it are isolated from each other when they are deployed within an Azure data center. The virtual machines that you place within an availability set are spread across multiple physical servers, racks, storage units, and network switches within Azure. If a failure occurs, whether it's related to Azure or your hardware, only a subset of the virtual machines is impacted. As such, the overall application remains up and running and availability is unaffected. Availability sets are therefore essential to a reliable cloud solution. When configuring an availability set, a number of fault domains and a number of update domains need to be set. Fault domains define a group of VMs that share a common power source and network switch within the Azure data center. Update domains refer to groups of VMs that can be then taken down at a single time. Configuring fault and update domains ensures that an application remains running during periods of planned maintenance of the underlying Azure hardware, as well as during unplanned hardware issues. Use availability sets when you want to deploy reliable virtual machine solutions within Azure. Now, to create an availability set, we need several commands. Availability sets are created using the new AZ availability set command. In this exercise, we are going to provision an availability set and then set the number of updates and fault domains as 2. The availability set will be called myAvailabilitySet, and it will be deployed to the VM Lab resource group. So we'll do this in the next video. I'll see you there. Creating an availability set requires just one command, new AZ availability set. To create a new availability set called myAvailabilitySet in the VM Lab resource group, run the following command, new AZ availability set, location East US, name myAvailabilitySet, resource group name VM Lab, SKU aligned, platform fault domain count 2, platform update domain count 2. This command typically completes rather quickly, and the output on your screen should look similar to mine. So after running this command, you've got successfully provisioned a new availability set 1. You can now deploy virtual machines to your new availability set. So let's create VMs inside an availability set. You can't add an existing virtual machine to an availability set once the virtual machine has been created. Virtual machine must be created within an availability set at the time of the deployment to ensure that they are properly distributed across the backend hardware. The hardware in a location is divided into multiple update domains and fault domains. An update domain is a group of VMs and underlying physical hardware that can be rebooted at the same time, whereas VMs in the same fault domain share common storage as well as a common power source and network switch. When you create a virtual machine with the new AZVM command, the availability set name switch is used to specify the availability set into which the virtual machine could be deployed. Deploying a new virtual machine into an availability set is virtually identical to deploying a virtual machine without an availability set. The only difference is the addition of the switch mentioned before. Before deploying any new virtual machines, you need to set an administrator username and password for the VMs by running the getCredential command. So we'll type $cred equals getCredential. With the local admin credential created, we can now proceed to creating 2 new virtual machines in availability set. To do this, run the following command twice to create 2 separate VMs, specifying myVM1 and myPublicIP1 for the first virtual machine and myVM2 and myPublicIP2 for the second one. All other switch values should remain the same. So we'll type this long one-liner. New AZ VM, resource group name VMLab, name myVM1, location East-US, virtual network name myVNet, subnet name mySubnet, security group name myNSG, public IP address name myPublicIP1, availability set name myAvailablitySet, credential $cred, and we'll run it as job. Run the same one-liner for the myVM2 virtual machine. Please note that as job parameter here creates the virtual machine as background task, so control of the PowerShell prompt returns to you. It takes a few minutes to create and configure both virtual machines, but when finished, you have 2 virtual machines distributed across the underlying hardware. Then you can type get AZ VM at the PowerShell prompt to see the status of your VM deployments. The command should look as mine on the screen. You can confirm that both machines have been added to the availability set by running get AZ availability set command. So you could type get AZ availability set resource group name VMLab name myAvailablitySet. And if you've done everything correctly, you should see a screen like mine, and you should have both myVM2 and myVM1 listed in the availability set. So congratulations, you have now learned how to create an availability set and how to create virtual machines within this. In this lab, you'll create an availability set, and the goal of this project is to successfully provision an availability set and to deploy 2 virtual machines to it. The key commands for this lab are as follows: a new AZ resource group, new AZ availability set, get credential, new AZ VM, get Azure, get AZ availability set. The exercise steps are as follows. First, create a resource group, then deploy an availability set. Third, deploy 2 virtual machines with the default Windows image into the availability set, and then install IIS on both virtual machines. Verify that the both virtual machines are listed in the configuration for the availability set. Load balancing provides a higher level availability by spreading inbound requests across multiple virtual machines. In these few videos, you'll learn about the different components of the Azure Load Balancer. You'll learn how to create an Azure Load Balancer, create a Load Balancer health probe, create Load Balancer traffic rules, use the custom script extension to create a basic IIS site, create virtual machines and attach them to a load balancer. You'll also view a load balancer in action and add and remove VMs from a load balancer. There is quite a bit to cover in these few next videos, so it may be a good idea to take a break before getting started. So some words about Azure Load Balancer overview. An Azure Load Balancer operates at layer 4 and provides high availability by distributing incoming traffic among healthy virtual machines. A load balancer health probe monitors a given port on each virtual machine and only distributes traffic to an operational virtual machine. A typical load balancer configuration can be illustrated like the following diagram. Although this diagram looks pretty simple, there is actually quite a bit going on behind the scenes. A fair of configuration is necessary to make things work. The deployment of a load balancer requires you to define a front-end IP configuration that contains one or more public IP addresses, which then allows the load balancer, as well as any application and VMs being load balanced, to be accessed over the internet. Since virtual machines are connected to a load balancer using their virtual network interface cards, a backend address pool must be created that contains the IP addresses of the virtual NICs connected to the load balancer. Traffic flow to the load balanced virtual machines is controlled with defined load balancer rules for specific ports and protocols. As we've already mentioned, there is quite a bit going on under the hood when it comes to load balancer in Azure. So creating an Azure load balancer. Next on the details how you can provision and configure each component of a load balancer. The following exercises create a load balancer called My Load Balancer in the VM Lab resource group in the East US location. So let's get started. Let's create a public IP address. To enable access to an application from the internet via load balancer, you need to configure a public IP address first. You can create a public IP address with the new AZ public IP address command. The following exercise creates a public IP address named LB public IP in the VM Lab resource group. So let's type the following one-liner. $public IP equals new AZ public IP address, resource group name VM Lab, location East US, allocation method static, name LB public IP. This command essentially creates a static public IP resource that will be assigned to a front end. In the other word, the public side of the load balancer. Now we have to provision the load balancer. With the public IP address provision for the load balancer, it's now time to provision the actual load balancer resource. Begin with configuring both the front end and the back end. Front end IP configuration is used to attach the newly created public IP address, which is LB public IP, to the load balancer. This configuration makes the load balancer available publicly. To create a front-end IP configuration, you should use the new AZ load balancer front-end IP config command, such a long command. So we'll run the following command to create a front-end IP config named myFrontEnd and to attach the LB public IP address to the load balancer. So we'll type $frontend IP equals new AZ load balancer front end IP config, name myFrontEnd, public IP address, $public IP. This command creates the configuration for the interface that will be used to access the load balancer publicly. Now we can create a backend IP address. Not IP address, but address pool. An Azure load balancer's backend address pool consists of IP addresses associated with the virtual machine NICs. This pool is used to distribute traffic to the virtual machines behind the load balancer. The new AZ load balancer backend address pool config command is used to create this pool. The VMs are then attached to this backend pool. So we'll run the following command to create a backend pool called my backend pool for the load balancer. We'll type $backend pool equals new AZ load balancer backend address pool config name my backend pool. This command doesn't generate any feedback. It just creates a backend configuration and then stores it in the $backend pool variable. Now we can create the load balancer resource. With the front end and back end configuration complete, you can now create the load balancer using the new AZ load balancer command. Create a load balancer named myLoadBalancer that uses the front end and back end IP pools created in the preceding steps by running the following command. We'll type $LB equals new AZ load balancer, resource group name VMLab, name myLoadBalancer, location East US, front-end IP configuration $frontend IP, backend address pool $backend pool. This preceding command creates a new load balancer resource, which is named myLoadBalancer, and stores the configuration in a variable called $LB. The configuration of the load balancer includes the front-end and back-end settings that were previously configured. Now we can create a health probe. To allow the new load balancer to monitor the status of an application or server, we first need to create a health probe. A health probe dynamically adds or removes virtual machines from a load balancer's rotation based on their response to health checks. By default, a virtual machine is removed from load balancer distribution after 2 consecutive failures at 15-second intervals. Health probe is typically based on a protocol or specific health check page for your application, in the case of load balancing IIS or web resources. Next up, we'll create a TCP probe that checks for port 80 availability in the virtual machines in the backend pool for the load balancer. The add AZ load balancer probe config command is used to create a TCP health probe. So create a port 80 TCP health probe for my load balancer by running the following command. Add AZ load balancer probe config, name my health probe, load balancer $LB, protocol TCP, port 80, intervals seconds 15, probe count 2. After creating the health probe, run the following command to apply the probe to the load balancer and to update it. We'll type set AZ load balancer $LB. After setting the load balancer's configuration, you should receive feedback that it was successful. With the load balancer provisioned, load balancer rules now need to be configured. Rules are used to define how traffic is distributed to the virtual machines sitting behind the load balancer. Defining rules in a two-part process. You need to define the front-end IP configuration for the inbound traffic and the configuration for the back-end IP pool in order to receive the traffic. Resource and destination ports must also be configured. Ensuring that only healthy virtual machines receive traffic through the load balancer requires you to define which health probe to use. The add AZ load balancer rule config command is used to create a load balancer rule. Run the following command to create a load balancer rule named myLoadBalancer rule that balances traffic on TCP port 80. The command will store the rule settings in the $probe variable, which is used in the following command. $probe equals get AZ load balancer probe config, load balancer $LB, name my health probe. Now you can run the following command to assign the newly created rule to the load balancer. We'll type add az load balancer rule config, name my load balancer rule, load balancer $LB, front end IP configuration $LB dot front end IP configuration 0 in square brackets, backend address pool $LB dot backend address pools 0 in square brackets, protocol TCP, front end port 80, backend port 80, probe $probe. This command adds the new rule to the load balancer using the add az load balancer rule config command, and if you've completed the exercise correctly, you should see the feedback like on my screen. At this point, the load balancer has been created and the configuration updated. So it's now time to update the actual load balancer with the updated configuration. So with all of the load balancer configurations complete, the load balancer itself can now be updated with the configuration set. This is completed by running the set az load balancer command. So we'll run the following command to update the my load balancer, and we'll type set az load balancer $LB. Running this command completes the configuration and deployment of the load balancer. At this point, it's time to deploy the virtual machines and connect them to the load balancer. Now, let's switch to network resources. Before you deploy and attach virtual machine to your new load balancer, the supporting network resources need to be prepared. Because we already have a virtual network in place, we don't need to create one. Instead, we will deploy our new load balanced virtual machines to my subnet on the MyVNet virtual network. To do this, we need to first store a virtual network and virtual subnet configurations in variables, so they can be referenced later. So to retrieve the configuration of the MyVNet virtual network, you'll need to use the getAZ virtual network command. This will retrieve the configuration of the MyVNet virtual network and store it in a variable called $VNet. So we'll run the following command to retrieve the MyVNet configuration. We'll type $VNet equals getAZ virtual network, resource group name VM lab, name MyVNet. This command will not produce any output on screen, as it's only pulling configuration information into a variable. In addition to the virtual network configuration, the subnet configuration must also be retrieved and stored in a variable for later modification. The getAZ virtual network subnet config command is used to retrieve the subnet configuration. Run the following command to do it. We'll type $subnet config equals getAZ virtual network subnet config, name my subnet virtual network $VNet. This command retrieves the configuration information for my subnet and stores it in the $subnet config variable. Now let's create virtual NICs. Virtual NICs are created with new AZ network interface. We'll run the following command twice, once for each virtual machine that will attach to the load balancer. The names to use for the NICs should be MyVM3 and MyVM4, so that they match the new VMs being deployed. And we'll type the following one-liner. New AZ network interface, resource group name VMLab, name MyVM3, location East US, subnet $VNet.subnets, 0 in square brackets, load balancer backend address pool $LB.backend address pools 0 in square brackets. And we'll do this the same one-liner for myvm3. It's important that you call your virtual NICs myvm3 and myvm4, because when you deploy the virtual machines in the following steps, the process will automatically attach the NICs to the corresponding VMs. Instead of creating new NICs, the virtual machine deployment process will simply update the existing NICs that you've provisioned. This simplifies the process of creating and attaching NICs. So, creating virtual machines. With a load balancer in place and configured, it's now time to deploy the virtual machines that the load balancer will load balance. The exercises in these upcoming sections will walk you through the process of creating an availability set as for best practice, as well as the deployment of the load balanced virtual machines. So first let's create an availability set. You learned about availability sets earlier in previous videos, so to conform the best practice, create a new availability set for your load balanced virtual machines by running new AZ availability set command. So we'll run the following command to create an availability set named new availability set. We'll type $availability set equals new AZ availability set, resource group name VMLab, name new availability set, location East US, SKU aligned, platform fault domain count 2, platform update domain count 2. The resulting availability set will host the load balanced virtual machines that are about to be deployed. Now it's time to set an administrator username and password for the VMs with get credentials. We'll type $cred equals get credential. And now we can create two VMs using the following command, repeating it for each new virtual machine. Call the first virtual machine myvm3 and the second virtual machine myvm4. And one-liner looks as follows. New AZ VM, resource group name VMLab, name myvm3, location East US, virtual network name myvnet, subnet name mysubnet, security group name new NSG, open ports 80, availability set name new availability set, credential $cred, and will run it as job. This as job parameter creates the virtual machine as a background task, so the PowerShell prompts return to you. You can view the details of the background jobs with the job command-led. Note that it takes a few minutes to create and configure VMs. You'll also run the following command for the second VM, which is myvm4. Now you can run the get azvm status command to ensure both new VMs are deployed and these VMs are running before continuing. It's important that you call new virtual machines myvm3 and myvm4. If the names of your new VMs do not match the names of the NICs you deployed, the virtual machine deployment process will create new NICs instead of updating the existing NICs. More importantly, your virtual machines will not be attached to the load balancer. To test the load balancer, you need to be able to determine which virtual machine you are connected to while testing. To do this, you need to install IIS on each virtual machine. You can do this manually and with the help of custom script extensions. So, to manually install IIS on your two servers, connect to myvm2, you can RDP into it and use that as a jump box to RDP into the private IP address of myvm3. You can get the private IP address for myvm3 by running the following command. Get AZ network interface, name myvm3, resource group name VMLab, It embraces .ip configuration .private IP address. After RDPing into MyVM3, install IIS on that server. When the installation of IIS is complete, open Notepad on this server virtual machine and create a file called default.htm in the C inetpub 3w root folder. Added this default.htm so that the only text in this file is myvm3, and repeat this process for myvm4, ensuring that the default.htm file for myvm4 consists only of myvm4 text. You can guess why you need this, and you can guess why you need to use myvm2 as a jump box, and why you have to RDP to the private IPs of myvm3 and myvm4 rather than their public IPs. It's because myvm3 and myvm4 both sit behind the load balancer, and we have not opened RDP via the network security group. Additionally, since both are behind the load balancer, their public IPs are the same. Once IIS has been installed on both VMs and the default.htm file has been created on each machine, you can test the load balancer. And as I said, you can perform these actions with the help of custom script extensions. And you can see it on my screen how to perform these manual operations with these custom script extensions. Completing these steps modifies the default page on each VM to display each respective virtual machine's name. This will allow you to easily see which virtual machine you are connecting to when you move on to test the load balancer. Now that the load balancer is configured and you have two virtual machines being load balanced by it, it's time to test the load balancer's functionality. Retrieve the public IP address of your load balancer with the following command: get az public IP address, and we'll type get az public IP address, resource group name VMLab, name LB public IP, select IP address. After retrieving the load balancer's public IP address, you can access the public IP address in a web browser. When the default web page is displayed, the host name of the virtual machine you are connecting to through the load balancer will be displayed. You might have to refresh your browser numerous times or even stop the virtual machine to see it connect to the second virtual machine. You can also add and remove VMs, and there may be occasions when you need to perform maintenance on the virtual machines that are running your load balanced application. Be it operating system patches, software updates, or otherwise, you'll find yourself needing to perform maintenance. After performing maintenance, you'll need to be able to reattach the virtual machine to the load balancer. So, to remove a VM from the load balancer, it requires you to retrieve the configuration of the attached NIC, detach the NIC from the load balancer backend address pool, and then to update the NIC. This process requires three commands. First, to retrieve the network interface card configuration, run the get az network interface command as follows: $nic equals get az network interface, resource group name VMLab, name myvm4. This command retrieves the configuration of the NIC for the myvm4 virtual machine and stores it in a variable called $nic. After retrieving the NIC configuration, alter it so that it's no longer connected to the backend pool by setting the load balancer backend address pools property of the virtual NIC to $null as follows: $nic.ip IP configuration 0 in square brackets dot load balancer backend address pools equals $null. And finally update the virtual NIC with the following set az network interface command. Set az network and the command looks as follows: set az network interface $NIC. Performing these steps will disconnect the MyVM4 virtual machine from the load balancer. To confirm, close your browser, reopen it, and browse your load balancer's IP address. The only virtual machine that should be servicing your requests is MyVM3. And of course you can add a VM to the load balancer. Whether it's because of virtual machine maintenance or the need to expand your capacity, you'll need to know how to add a virtual machine to the load balancer. To do so, simply set the load balancer backend address pools property of the virtual NIC to the back address pool. Reattaching MyVM4 to the load balancer requires 4 commands. Begin the process of reattaching MyVM4 by running the following command: $LB equals get az load balancer, resource group name VM lab, name my load balancer. This command retrieves the load balancer configuration for my load balancer and stores it in the $LB variable. After retrieving the load balancer configuration, run the following command to retrieve the configuration of the virtual NIC for MyVM4 and then store it in a variable called $NIC. So we'll type $NIC equals get az network interface, resource group name VM lab, name MyVM4. After retrieving the NIC configuration with the preceding command, run the following command to attach the NIC to the backend pool of the load balancer. So we'll type $NIC.IP configurations 0 in square brackets dot load balancer backend address pools equals $LB.backend address pools 0 in square brackets. After connecting the NIC for MyVM4 to the backend pool of the load balancer with the previous command, run the following code to update the NIC configuration to complete the process. So we'll type set az network interface $NIC. And after completing the preceding step, you can restart your browser to confirm that both virtual machines can now service requests. You can also run get az load balancer status for connection confirmation. So this section was quite a long one and with lots of steps where you created a load balancer, attached virtual machines to it, and then removed virtual machines from it. You also learned how to create an Azure load balancer, create a load balancer health probe, create load balancer traffic rules, and create virtual machines and attach them to a load balancer. We viewed a load balancer in action and added and removed VMs from a load balancer.